Talking about statistical process control and producing the control charts for X bar, the average, and for measures of variability. In statistical process control, there are two types of variability: the range, R, which is your max minus your min, and your standard deviation. Okay. So statistical process control is a method that's used to monitor the production typically, or a process over time. It doesn't have to be production, and to see it and to make sure that things are being produced properly. For instance, to make sure that on average things meet specifications. In addition to making sure the average meets specification, you want to ensure, so that is, you also want to monitor the variability in your production, hence the standard deviation control chart and or the range chart. Okay, so to produce the X bar chart, or you need to calculate the upper control limit, the lower control limit, and the center line. The center line is just the average. The upper and lower control are the overall average, plus or minus A2 times the average range. So this is using the range to estimate variability. Okay. Now A2, that is a value that comes from a distribution, just like when you calculate confidence intervals. When you calculate confidence intervals, for instance, it can come from various distributions, such as a normal distribution, such as a t distribution, such as an f distribution. And here, this A2 comes from a distribution you've not heard of, and so you're just provided the table for it, how to obtain its value. Okay. Instead of using range charts for the X bar chart, you can use standard deviation. So, for example, you would calculate the overall average plus or minus A3 times S bar, the average standard deviation. Okay. Then for producing charts for variability, there's two of them. One of them is the range chart, or R chart, and that monitors the spread of the process. And the formulas for calculating this, so you'll calculate R bar, the average of the ranges. Then you'll calculate the upper control and the lower control, which is D4 and D3 times the average range. Okay. Again, D3 and D4, they come from unknown distributions, unknown to you, that is, and their values can be found via a table. Okay. Now, the S bar chart for standard deviation, it has a center line, which is the average of the standard deviations, then B3 and B4 times S bar. Okay. Again, B3 and B4, those come from a chart or a distribution. Okay. So for the chart, you can just use this chart, and here's the values of A2, D3, D4, A3, B3, B4, etc. And it depends on the sample size. So for 2, 3, 4, 5, etc. So we only list up to 10, but for example, if you wanted to know what the values were when you sample 5 parts, you would use that row of values, and then you'd find the corresponding A2 or B3 values or A3 values, etc. So the values here are calculated to ensure that they encapsulate about 99% of the variability in the data. So 99% of the outcome should be captured in this range chart. So it would be highly unusual. So for example, the range chart or the S chart or the X bar chart, they should all contain about 99% of the data. So it'd be pretty unusual to have an observation outside of the control limits, the upper control limit or the lower control limit. Okay. So these charts are used to identify unusual observations and to try and let the engineer or the person in charge find what's called an assignable cause variation rather than random chance. Because if it's outside of 99% of the outcome, it seems unlikely to be due to random chance to have a value that extreme. Okay. So the example that we're going to consider is the syringe length control charts. And we're going to produce the X bar chart, the range chart, and the S chart. Okay. So in this example, people are going to measure the syringe length, and the quality control engineer is going to collect 20 samples over time. So in the first sample, say week 1, they go and they collect a sample of size 5 and they calculate the measurements. Then they go to week 2, they take a sample of size 5, they record the measurements. They repeat this for 20 weeks. Okay, and the data that they collect, this is the data for the syringe length for week 1. Okay, so 4.96, 4.946, 4.95, etc. So that's for week 1. Then for week 2, they get 4.958, 4.927, 4.935, etc. And they repeat this for 20 weeks, and they get this matrix of observations, where the first column is the first observation, the second column is the second, all the way up to the 5th observation in the 5th column. Okay. So here they calculate the means of each week. That's the subgroup means, and then they calculate the subgroup ranges. Okay, so they calculate the max of week 1 minus the min of week 1, the max of week 2 minus the min of week 2. Okay, then they do the same for the standard deviation. Okay, the overall statistics, they calculate the overall average, so that is the average of each week's average. Then for R bar, they calculate the average range over each of the 20 weeks. And then for S bar, they calculate the average standard deviation. The standard deviation is calculated in each week. Okay. Now they're going to calculate the R chart values. So they do the upper control limit for the range chart is D4 times R bar. The center line is the average range, and the lower control is D3 times R bar. Okay. They proceed to use the formulas for X bar, for S bar, and they go ahead and calculate this. So the range chart limit is 0.046 from the max to the min in the upper control. The lower control is 0. Okay. Then the center line for range is 0.02. So the average range is about 0.02 units of length. Then for the X bar, they calculate that the upper control is 4.97, the average is 4.96, and the lower control is 4.948. Okay. So this was using R bar. They calculate the S bar here for the variation, and the standard deviation control limits are 0.0186, the center line is 0.0089, and the lower control is 0. Okay, and then they also calculate the X bar chart using S. Okay, and you're welcome to use either. I slightly prefer the S because you can typically do either when you have the raw data. Now you want to visualize it. This is what the graph looks like over 20 weeks. So the X bar chart using the range, it looks like this. And so we can see in the second week it was out of control. The average was too low, and that is too low to be due to random chance, so you'd have to go and investigate what happened between week 1 and week 2 to bring this out of control. Was there some sort of systemic problem in the production of these syringes? Okay, then it goes back up to about average. Then from week 10 all the way to 17, we see a lot of variation here. And that's going to be reflected in the R chart and the S chart. But we can see that there's a lot of variation and that this is kind of trending out of control. And then there's a problem again in week 16. And then it kind of seems high. So it remains high, but it's within control. Okay, so again, there's some assignable cause variation, and you probably want to investigate from week 10 up to 16, but in week 16 it culminates to be out of control. Now we see this in the range, right? The variability keeps increasing in the production, okay? And we see that in week 8 here that the variability is out of control in the R chart, and so there's something going on with the variability, not the average here. And so you have to go to your production line, you have to talk to your managers, you have to say what could be going on that produces this. Okay, and the S chart reflects the same thing here. There's a problem in week 9. Okay, and there's also concern leading up to that. So there's the variability is increasing into week 3. Okay. Okay, so this was the X bar, the X bar chart, the R bar chart, and the S chart. Let's consider a new problem. So here, a quality control engineer monitors the weight of cereal boxes, so how much cereal they're putting in the box. They take samples of n = 5, and they repeat this process over 20 observations, or 20 weeks, 20 months, whatever you want to assign the unit of time for 20. And it's calculated that the average here over the 20 weeks is 320.4, and the sum of the ranges is 12.8. We want to use this information to calculate the control limits for the X bar and R charts. Okay, so here the number of samples is 20. Each sample has a subgroup size, or a sample a size 5. The sum of the subgroup means is 320. The sum of the subgroup ranges is 12.8. And now we can use this information. We know there's n = 5 samples to get the values of A2, D3, and D4 to calculate the upper control limits, the lower control limits. Okay. It should be pretty easy to calculate the center line because that's just the average. Okay, so A2, D3, and D4, you're going to go to the sample size here of 5, and we're going to say A2 is 0.577. Okay, the A2 value is going to be this 0.577, and we need also to calculate D3 and D4. So D3 is 0 and D4 is 2.114. So that's how we calculate the values of this right here, is from that chart. Okay. Now we calculate the overall average, so we take our sum of the overall mean, divide it by 20, we get 16. The overall range, we take the 12.8, divide it by 20. And now for our R chart calculation, we get our center line is that 0.64, The upper control limit, we just take D4 times R. So this 2.44, 2.44 we got right here. Okay, 2.44 right here, because we know n is 5. We want to look up the value of D4. Okay, so 2.44 times 0.64 gives us 1.35. The lower control is 0 times the 0.64, so lower control is 0. And our X bar chart calculation, the center line 16.02. Then we take that 16.02 and add A2 times R. So A2 is 0.577 times this 0.64. That gives us our average of 16.389. Okay, the lower control, we just subtract that second half, we get 15.65. And this is an example of constructing the upper and lower control charts, in particular finding the upper control limits and the lower control limits for an example problem like this, and you would use this table. Okay, thank you very much.